Hello everyone and welcome to Noob Engineering. Today's lecture number 5 that will be conducted on safety controls and its types. So without wasting time, let us continue to our topic, that is types of safety controls. Okay. So what is a safety control in HVAC? Okay, or HVAC. That is a safety control in HVAC or HVAC is a device that is used to protect the HVAC system from damage and to prevent injury to people and property. Okay, safety controls are typically designed to shut down the HVAC system if a hazardous condition is detected. Now, what do you mean by a hazardous condition? Okay, the hazardous condition may be differ if the pressure gets more, or the temperature gets more, or the temperature gets too low. Okay, these are the conditions where the safety controls plays an important role in HVAC. Okay, now let's see how many types of safety control devices are given in the exam. Sorry, in the syllabus. Okay, types of safety controls. So there are three types of main safety controls given in a syllabus that occurs in the exam. Okay, that's why I have taken this all three. First one is LP-HP cutoff. Okay, low pressure, high pressure cutoff. Second one is low temperature cut. Okay, and the third one is frost control. So let's begin with the first one, that is LP or HP cutoff. Let's see. So what is an LP HP cutoff? So a low pressure, that is LP, and high pressure HP cutoff system safety valve is a device that is used to protect the refrigeration or air conditioning system from damage. Okay, ये तो safety devices का work ही है. Okay, this could be the first line you can say about what is an LP or HP cutoff system. Okay, it works by stopping the compressor if the evaporator pressures drop below a certain threshold, that is LP cutoff, or if the condenser pressure rises above a certain threshold, that is HP cutoff. Okay, now the LP is basically works for compressors. Okay, and for HP it works for condensers. So what is an LP cutoff system? A LP cutoff is designed to protect the compressor from damage by liquid refrigerant. Now, how it protects it? Okay, if the pressure increases, the liquid ref the means as the pressure increases or drops below a certain threshold point, it could mean that there is a liquid refrigerant in the compressor suction line. Okay, are you understanding? Are you understanding? It means it could mean that there is a liquid refrigerant in the compressor section line. So we have studied evaporators. Okay, now if we take an flooded type evaporator, here is a diagram of any flooded type evaporator. Here would be the baffles. Okay, this is a baffle or a filter, and here it will be a suction line. Okay, now the evaporator tubes come here and goes from here. Okay, this was a flooded evaporator type, a flooded evaporator. Okay, now if the vapors were going from here, simultaneously the baffles were stopping the liquid particles from going into the suction line pressure. Okay, yeah, this one. Now this LP cutoff system, what does it does when there is a in suction line pressure, there if the liquid refrigerant enters here, it would harm the compressors. Okay, it would harm the compressor. It is not good for when a liquid is moving in the compressor, liquid particles are moving in the compressor, it harms the compressors. So as the pressure drops in an evaporator, then evaporator coils, then the LP what does the work of cutting off the compressor, okay, means stopping it to work. This is a simple work of a LP cutoff system. Okay, and what is a high pressure cutoff? So as to protect the the HP is designed to protect the compressor from damage caused by high pressure. Okay, if the condenser pressure rises and above certain threshold point, it could mean that the compressor is being overloaded. Okay, the high pressure can damage the compressors. Okay, so the HP will cut off and stop the compressor to prevent from this happening. So the working of both the devices, that is HP and LP, is to stop compressor. Okay, when there is a high pressure or a low pressure. Okay, now how does it does? Let's see. So this is a diagram I have taken from the book itself because there were no diagrams available on the net. So this is for this diagram. Let me confirm. This is for high pressure. Okay, and this is for low pressure. Okay, now let me tell you the components here. These are the bellows. It nothing but the type of a moving plates. Okay, these are the plates you can see here. Have you seen this structure somewhere else? These are the this it expands also and it contracts also. On the basis of this, these two contacts are separated from each other or attached to each other. Okay, and this is a suction line pressure. Okay, now as the pressure increases here, the pressure is increasing. These bellows will expand. Okay, with the help of the spring, it expands. It can move till here. Okay, it will come till here. This bellows is situated till here. Okay, then what happens? This will get these both are the switch. It will get contacted. They will come in contact, and as it comes in contact, the working of this is it offs the compressor. Okay, and here is the same working of it. It is also simple. The components are same, but these this system is placed here because of the low pressure working. Okay, if this comes down, okay, if the pressures fall down, the bellows will, okay, the bellows will shrink. The volume of this will decrease of the bellows. As the volume decreases, this bellows will come here. Okay, this bellows will come here. It will continue like this. Okay, as the bellows come till here, these both again get in contact. Okay, as this get in contact, it offs the compressor. Offs compressor, and as a result, the compressor is safe. Okay, now let's move on to the working of this both. See here. First one is high pressure cutoff switch, that is monitors the pressure in the refrigerant line, shuts down the compressor if the pressure rises above a certain threshold point, and this prevents the compressor from being overloaded and damaged. And the low pressure cutoff, see only this line changes. You can see here this one pressure drop, here it is pressure rise, baki all are same. So It's simple, very simple. In low pressure, pressure drop. It If the pressure drops, the compressor is off. And in high pressure, if the pressure is high, the compressor is off. Okay, this is the simple working. Now let's move on to the second one. So next one is low temperature control. Okay, so what is low temperature safety device control? Low temperature safety controls are used to protect HVAC systems from damage caused by freezing. Okay, they are typically used in applications where the evaporative coil is exposed to low temperatures, such as commercial and industrial refrigeration systems, chillers, and air handling units. Okay, now these are used where the extreme temperature level is dropped. Okay, it might be in industries where there might be a very low temperature needed, but it is also at a threshold point or a set point. Okay, you can call it as a set point. If the temperature if drops below this also, then there is a problem. Then it cuts off, once again it cuts off the compressor. Okay, and makes a stop. And what are the components of this low temperature control valves? It is contacts, blades, bellows, and sensing bulb. Okay, let's see the big picture. This also diagram I have taken from the book because it was not available on any of the it was not available on the internet. Okay, now as you can see, here is one sensing bulb. Okay, now why this sensing bulb is provided here? It is provided here because it senses the temperature of the substance or any other thing that is placed here. Okay, if the temperature decreases here, it senses below the threshold point, it goes down below the threshold point or a set point, it senses. And as it pressure is decrease means what temperature decreases, the pressure also decreases. And as the pressure, sorry, because of the high pressure, the bellows will expand here. Okay, the bellows will expand, and this both switch relays get in contact. Okay, as it gets in contact, hmm, as it gets in contact, the compressor work shuts down. Okay, this is the simple working of a low temperature safety valve. So first will be the filler bulb senses the temperature of the evaporative coil. Okay, in this it senses the temperature of the evaporative coil here. Okay, if the temperature of the evaporative coil drops between a certain threshold point, the pressure in the filler bulb decreases. Okay, filler bulb. Okay, the pressure in the filler bulb decreases. Okay, not in the bellows. The decrease in pressure causes the low temperature control to open. Okay, when the low temperature control opens, it sends a signal to the compressor to shut down. Okay, this prevents the evaporative coil from freezing and being damaged. This is a simple working of a temperature control. Let's move on to the last one, that is the frost control safety device. Okay, now what is a frost control? Frost control is nothing but, you can have you seen a refrigerator full of ice sometimes? That is nothing but the frost. Okay, we call it as frost. So to control that, it is a system that prevents the evaporative coil in a refrigeration or air conditioning system from freezing. This can be done by shutting off the flow of refrigerant to the evaporator coil when the temperature of the coil drops below a certain threshold. Frost control is important to prevent damage to the evaporator coil and ensure that the system continues to operate efficiently. Now, this is the whole VCR cycle of an frost control, how it is used in how a frost control is used uh, or work. Now, okay, let's see. So, this is a diagram of an frost control safety wall or a safety device. Okay, it is a full VCR cycle here. Okay, now let's make me a correction here. Here will come one filler bulb. Okay, now it's good. And here it is connected. Okay, now here is a compressor, here is a condenser, here is a solenoid valve, here is an expansion valve, and here is an evaporator. So you know the workings of an compressor, that is pressure increasing and temperature increasing. Okay, what is the function of a condenser? A condenser basically converts the vapor refrigerant to liquid refrigerant. Okay, and what does the work of solenoid valve? A solenoid valve controls the flow of liquid refrigerant LR. And what does the work of expansion valve? Expansion valves basically it decreases the pressure and temperature. Okay. Now, what is the function of an evaporator? An evaporator converts a LR, liquid refrigerant, that is LR, into vapor refrigerant by cooling the substance. Okay, substance that could be any. Okay, and here is the filler bulb. This is the filler bulb, FB, not Facebook. Okay, FB is a filler bulb, and suction pressure control valve. You can use it as an extra. Okay, now how does it works? If the pressure drops here in the filler bulb, okay, pressure drops means what would be the temperature? It is increasing or in decreasing order? Obviously, it will be in a decreasing order as the pressure decreases, as the temperature decreases, the sensing element sense and sends a signal to the solenoid valve telling that it should cut off. So it will tell um, that to open the solenoid valve to pass on the liquid refrigerant in the expansion valve. Okay, this will make a certain or means what we can say develop a certain pressure or maintain a certain temperature. Okay, pressure and temperature. Okay, again by doing this we can overcome the frost that is being in our what we can say in anything. We can say it is in or refrigerator. Okay, it could be in a refrigerator the frost, or it could be in a industrial areas where we do not need a frost. Okay, on the evaporator coils. Okay, just is a simple working. As the pressure decreases, the temperature decreases, the pressure decreases in the filler bulb. As the filler bulb senses the temp decrease in pressure, and it sends to the sensing element to the solenoid valve. The solenoid valve just opens the pressure valve. Sorry, and the solenoid valve is open, and the liquid refrigerant enters to the expansion valve. At it enters it. It's move further and it is operated and the works is done. It will maintain the temperature and pressure again. Okay, and by not letting it to frost. Okay, Let's see the working here. This is the working of a frost control safety device. The filler bulb senses the temperature of the evaporator coil. If the temperature of an evaporator coil drops between a certain threshold, the pressure in the filler bulb decreases. Okay, as I discussed. This decrease in pressure causes the solenoid valve to open. Okay, when the solenoid opens, it allows refrigerant to flow from the evaporator coil. Okay, the refrigerant evaporates in the evaporator coil, cooling the coil and the surrounding area. As the temperature of the evaporator coil rises, the pressure in the filler bulb increases. Okay, and this increase in pressure causes the solenoid valve to close. And when the solenoid valve closes, the flow of refrigerant to the evaporator coil stops. As simple as I explained back. Okay, now here we finish the two chapters of our first unit. Okay, now our first unit, that is the unit number 3, is completed. Now from tomorrow we will start a new chapter, that is unit number 4. Okay, before going, I would like to tell you, if you're directly coming and seeing this video, that is this is the fifth lecture, please go and see the first 4 lectures for better understanding. Okay, the first 4 lectures would I have conducted on. The first lecture was on compressor, second lecture was on condenser, the third lecture was on evaporator, and the fourth lecture was on expansion, and the fifth lecture, this is on the safety devices. Okay, and as regularly I will provide all the notes on my Telegram channel. Please do join and subscribe, and lastly, subscribe the channel if you like the video, and see you in the next lecture. Bye, take care.